Today video I am going to show you that Lewis structure, geometry and bond angle of a compound. So first, to determine that Lewis structure, you need to count that steric number. So you can also see that whole whiteboard I draw a lot of structure. So this is just a common concept. So before going to that Lewis structure, you need to know that steric number. Then we will go that geometry and the effect of that lone pair. So first, to determine that steric number, you need to know that single bond is count as 1 and double bond also is count as 1, triple also count as 1 and lone pair also count as 1. So to determine that steric number, I can give you an example, right? So we already know that structure of water molecule, right? So in that water molecule there is 2 single bond, right? So 1, 2 and 2 lone pair, 1, 3, this is 4. So 1, 2, 3, 4. So this number are count as steric number. So any kind of compounds like ammonia, you can see that structure. So ammonia has 3 single bond, right? Single bond which will count as 3 and 1 lone pair which will count as 1. So ammonia also have like 4 steric number. Okay, so when we count that 4 or any steric number, then we can go through that general topics and we can go through that Lewis structure, geometry and bond angle of any compound. Okay, so in this video I'm going to show you specifically that compound chlorine F3 and its structure, Lewis structure, then geometry and bond angle, and at the bonus point you can see that the lone pair electron has a clear impact on their bond angle. So I'm going to also share that things. So let's start. We need to find out that valence electron first. So valence electron of that chlorine is 7 and also fluorine has 7 valence electron which is multiplied by 3 because there is 3 fluorine, which it makes 28 valence electron of that compound. Okay, then we need to find out their Lewis dot structure. So Lewis dot structure, before go to that we need to find out which one will go to that middle of that structure. So least electronegativity element is go to that middle point. Okay, so you can see that chlorine has 3.16 and fluorine has 3.98, which is almost 4 electronegativity. So obviously this chlorine will go to that structure middle point. So let's draw that Lewis dot structure. So chlorine has 7 valence electron. If I put that 7 valence electron like that, then I will put that fluorine 3 side of that chlorine and I will put that dot here because fluorine also has 7 valence electron. So it is like that. Then I will make that bond here. So one will go here, another will go here. Then you can see that bond here. So it makes a single bond with that fluorine. Okay, then you can see that that one and that one makes another pair of lone pair. So chlorine has, if I redraw that, so chlorine is here, then fluorine, fluorine and fluorine. So I'm not worried about that fluorine lone pair because it is not in the middle, but chlorine, that one and that one, this makes another lone pair. So chlorine has another lone pair, so it has 2 lone pair. Okay, so we draw that Lewis structure. Then we need to find out their steric number, which is 3 single bond, that's mean 3, and it has 2 lone pair, that's mean 2, which makes it 5, right? Then we need to match that 5 number with that table. We already draw that. So this 5, right, is here, steric number 5. Then we have 2 lone pair, that's mean 2 means here, right? So it will come here and this shape. So it will get T shape, which is like that. So I have chlorine, that 2 lone pair and I have 3 fluorine, which shape is like that. So this shape is known as T shape, because you can easily figure out that it is looks like T. And then you can see that that value is little lower than 120. So their angle will be less than 120. So generally it should be 120 if there is no lone pair electron. So you can easily see that lone pair impact on that bond angle, which makes 120 without lone pair, but if you have 2 lone pair, then it will be less than 120. So you can see that lone pair impact on that bond angle. You see that geometry, which is T shape, and Lewis structure, which is that. So I think you got that. Thank you.